Hey everybody, this is our second video for our fourth standard. Now the first video was the introduction that we actually kind of did because we needed to know how to simplify radicals when we were solving for solving our quadratics. So the first video was then. So we're going to see what else we can do with these complex numbers. So it's going to seem a little bit different than anything we've worked with in this unit, but it is kind of finishing this idea of what can we do with complex numbers. So we're going to be working with operations. So adding, subtracting, multiplying, and dividing complex numbers. So let's go ahead and get started. So let's review what a complex number is. A complex number is in the form of a plus bi, where a and b are real. But b is the coefficient, meaning the number in front of the imaginary part. So we always write it with the real piece first, a, plus the coefficient, which is also real, like a 7 or a square root of 3. It doesn't have to be rational, it just has to be real, times the imaginary part. So what makes it complex is that it's made up of a real piece and an imaginary piece. And that's why we call it a complex number. So we're going to start by adding and subtracting some of these. So I'm going to give you an example and we're just going to add it together. So if I have, for example, 3 plus 2i, and we kind of use parentheses not because it requires parentheses, but because that tells you that this is the complex number. And I want to add it to negative 5 plus 7i. So again, I've got these two complex numbers. If I didn't write them with parentheses, you may not know which real part goes with the imaginary part. So these are two different complex numbers being added together. The parentheses are only to tell you what makes up the complex number. I hope that makes sense. So now when I want to add these, I want to add the real parts and I want to add the imaginary parts. So I would add the 3 to the negative 5 and get a negative 2. I would add a 2i to a 7i and get 9i. So when you add two complex numbers, the result is a complex number. Let's go ahead and try subtracting. So if I had, let's say, 6 minus 4i, and I wanted to subtract negative 2 plus 5i. Okay? So again, I'm going to combine the real parts and the imaginary parts. So for this, I have to subtract both of these pieces. I have to subtract the negative 2 and I have to subtract the 5i. So I might want to rewrite this as adding a positive 2 and subtracting the 5i. So again, the parentheses are only there to show you what the two complex numbers are. But once I go ahead and do this, I get 8 minus 9i. So this is just two examples of adding and subtracting. Multiplying. There's different ways we could multiply complex numbers, or at least the problems look different when we approach them. So for example, I may have a complex number 3i. You're saying, well, where's the real part? In this case, the real part is 0, kind of like 0 plus 3i. So I'm going to take that and I'm going to multiply it by another complex number. How about 4 minus 6i? So in this case, I'm actually just distributing. So I have 3i times 4, which makes 12i, and 3i times negative 6i, so that makes a negative 18i squared. So we're going to talk more about the powers of I in our next video, but I have to clear this up now. I squared has a value of negative 1. You say, well, how is that possible? Because I actually represents the square root of negative 1. So if I were to square it, as in squaring both sides, I would have I squared equal to negative 1. So it's important that we know this because we're able to simplify this right here and make that 12i minus an 18 times a negative 1, which really means plus 18. So 12i plus 18. And if we want to write it in the correct form, I'd write 18 plus 12i. So this is the result of distributing the 3i onto that binomial. We're going to try another one where I have a binomial times another binomial. So here I have 5i, and I say binomial, it's really complex number, but we can look at them as the pieces. So a complex number times a complex number. And I would recommend you go ahead and use that multiplication table, the Punnett square. And it doesn't matter where you write it, 5 plus I, and then 4 and a negative 3i. And we can multiply within this box. That gives me 20, gives me 4i when I multiply 4 times I, negative 15i, and here I have negative 3i squared. But keep in mind that this negative 3i squared is actually a negative 3 times a negative 1, so it's really like a positive 3. So if I have 4i and a negative 15i, that means I have negative 11i. And if I have a 20 and a positive 3, I have 23. So the result of multiplying these two complex numbers together is this complex number. All right, the last thing we're going to look at is dividing or rationalizing. And I'm going to start very simple. I'm going to start with a complex number, 3 plus 2i, and I'm going to divide it by 4i. Now, the idea here is that I'm rationalizing, which means that I need to get the irrational part out of the denominator, to get the irrational part out of my denominator. You say, well, I don't see an irrational part. Well, I is irrational because I represents the square root of negative 1. So in fact, there is a radical in the denominator. Well, we know a way of getting rid of it. It's if we multiply it by another I, creating an I squared. So I need to multiply this by another I in order to get rid of the imaginary piece in the bottom. Again, my purpose is to create an I squared because we know I squared is negative 1, and that just comes from squaring I, or squaring the square root of negative 1. So why am I multiplying by I over I? Well, if you remember rationalizing square roots, which you may or may not, I'm multiplying, in a sense, by 1 because anything over itself is multiplying by 1. So I'm not changing the value, I'm changing its appearance. That's really important to understand. I'm not changing the value, we're changing the appearance. So we're changing the look of it, not the value. All right, well, let's go ahead and multiply. In the numerator, it's just distributing an I. So I get 3i plus 2i squared. In the denominator, I get 4i squared. Now let's take care of those I squareds. So in the top, this becomes 3i minus a 2. Well, why? Because I squared is negative 1. In the denominator, it becomes negative 4 because I squared is negative 1. So let's fix this up because this isn't quite in the right order. We need to write the negative 2 plus 3i, and we're going to divide that by a negative 4. If it bothers you to have the negatives in the two places, you can switch it. This would also be an acceptable answer. 2 minus 3i, all divided by a positive 4. Notice how I switch the signs everywhere. So both of these are acceptable answers. Let's try one more division problem. I'm going to again start with a complex number, but this time I'm going to divide it by a little bit more, strange looking 5 plus 3i complex number. So the point is that I have the complex divided by a complex. Now this type of rationalizing is going to look a little bit different because if I just multiplied by I would cancel the I here, but I would create an I over here. So I don't want to multiply it by I. This time I want to multiply it by something called the conjugate. And a conjugate in mathematics is where I change and I make it the opposite, because it will then, if you remember this from the difference of perfect squares, it cancels out the middle. So in the top here, again, I multiply it by exactly the same thing. Now I chose to use the conjugate of the denominator because that's where I need to rationalize. That's where I need to get rid of the radical. So in the top, I'm going to multiply these out, and I can use the Punnett square if we want to make a quick one. So it's 1 minus I and 5 minus 3i. That makes a 5, a negative 5i, a negative 3i, and a positive 3i squared because it's a negative I times a negative 3i. But we know that this is going to turn into negative 3. So when I combine all of that together, I get negative 8i plus 2. I'm combining these two and I'm combining these two together. In the denominator, I have to do the same thing. But what's really awesome about this is that I know that my two corners are going to cancel because I have 5 plus 3i and 5 minus 3i. So I know these two are going to cancel because they'll be opposites. So I have 25 and 9i squared. Well, 9i squared is really plus 9. It's a positive 9 because I squared is negative 1. So 25 plus 9 makes 34. So the only thing I can do left, this is one last thing, is that all of these are divisible by 2. So negative 4i plus 1 all over 17. And that is my final answer. Please go back and look at all of these steps, and if you need to, rewind it and listen to me again. All right, so here are your try these problems. I want you to give them all a try. The first one's some subtraction. The numbers 2, 3, and 4 are all multiplication. And then number 5 is one division problem that I'd like you to try.